Welcome back to my YouTube channel KS Electrical Automation. So today in this lecture we are going to see about logic gate. First we are discuss about logic gate theory. Then step 1, first discuss about logic gate theory. Step 2, logic gate truth table, and step 3, PLC program of logic gate. Then communicate PLC to PLC Studio 5000 Logic Emulate to Studio 5000 Logic Designer software. So let's get started. So here a logic gate is a device that acts building block for digital circuit. So they are perform basic logic function that function to digital circuit. Digital circuit means on, off, true or false. Digital circuit means on or off, true or false, 0 or 1. In circuit, logic gate will make this decision based on the combination of digital signal coming from the input. Means digital signal coming from the input. There are three types of basic logic gate. First, it is a basic logic gate. So three types of basic logic gate. First is AND gate. In this lecture only I discuss about logic gate and AND gate and OR gate, AND gate, NOT gate. So first OR gate. So the OR gate is digital logic gate that implement logical disjunction and or produce a high output when any one input is high. It produce low output when all input is low. So I know about you are already know about logic gate and theory. So it is a truth table of logic gate, two input or truth table logic gate A, B and X. Symbol of OR gate and OR gate. In OR gate, A, B, X. A, B as an input, X as an output. So in first condition, so let's open the software and test of the logic gate condition of truth table. Just right click and select new program. Right here new program, main program. So just like anything, main program, first program, anything based on your requirement. You just like anything, main program, first program, new program, all basic logic. Parent non use folder as a schedule, main task, then click on OK, then right click on program, click on add, click on new routine, just write here main routine, type here, select the select which type of used language. So in assignment main is a by default first routine is a main routine. So click on open routine. So in first routine and close. Just explain what is do you mean by first routine. So main routine is a it is a main routine. In main routine, when I create another routine, so all another routine call in main routine. All another routine call in routine. Just example, so another routine will be create. So another routine has been created. Logic gate. So in main routine, it is a simple. What is the work of main routine? So main routine work is a very simple. When we create another routine means subroutine, main routine and it is a subroutine. So when how to call subroutine in main routine? Just like right here JSR or simply JSR jump to subroutine logic gate. When I when we don't take in main routine when we don't call in main routine to subroutine when we don't call in main routine of subroutine, so we not able to run the logic of subroutine. Just logic gate input 1, input A, input B and output, input A, input B and output, 2 input and 1 output. You click on local tag, create a tag, monitor tag and edit tag. We can monitor from monitor tag and we can edit on it, create tag. Just like right here, input 1, data type bool, because input it is only 0 or 1. Just like copy and paste it and paste it, paste it, paste it, copy and paste it here. Output 1. So tag has been created. Then take a just right here input 1. In logic gate, when input number A 0, input number B 0, then output should be 0. Okay. And when input A when input A 0, input B 1, then output will be 1. Then when input A 1, out input B 0, then output will be 0. When input A 1, input A 1, output is 0, then also output will be 0. Means when any one input, when in A condition or B condition, we can observe here when any one input on, then output will be, sorry, how to make logic for OR gate, just like here, right here, take a branch, paste it. One more thing, when I one more thing, when we take input, when we take memory bit, so take from here for memory bit.
So in this case output 1 is will be 1. So this is a OR gate. Next AND gate. So in AND gate condition, So create a new tag. It is a it tag is it 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 tag is memory tag. So in memory tag we have required base. Click on here, create, and right click another input, click on new, click on create, and output 2, output underscore 2. Okay, sorry, output 2, and control W, just accept and edit program, and again run and save. So let's check and get truth table how to satisfies in logic. So first condition of AND gate is if input 1 0 means A 0 B 0, then output will be 0. So its first condition is true, both input are 0 and output is 0. If second condition, if input A is 0, input B is 1, then output will be 0. So just check. If input A is 1, so we can see output is 0. Next, this condition is satisfies. Second condition, if input B is 1, then output B. If input B is 1, then output is 0. So if input 4 1, so input 4 just like input B, and input 3 just like input A. So if input B means input 4 is 1, then output will be 0. So AND gate, in AND gate, if both input are 1, then output will be 1. So input 4 also 1, input 3 will be 1, then we can see output 2 will be 1. And my next gate is a NOT gate. So in NOT gate condition, first theory, in NOT gate it produces high output when input is low, vice versa. Gate also called inverter gate. So truth table is here, input A and output A. In NOT gate condition, only one input and only one output. So if input A is 0, then output Y. If input 0, then output 1. If input 1, output 0. This is simple, because in OR gate we know that OR gate required bar, Q equal to A bar. So A bar means A equal to 0, so 0 bar equal to 1, and A equal to 1, to 1 bar equal to 0. So let's see how to satisfy in the Logic Studio 5000. So just change controller mode, remote run mode to program mode. Click on S, then take a run and take a no. Right here, input 5, and just control W, double click, output 3, control W. XIO, we can write XIO or NC. So just select run mode, change controller mode to run mode, click on S, and we can see again accept finalize edit program, click on S. Let's check how to satisfy or not gate in the program. So if input A is 0, then output is 1. We can see input A is 0, but input A is 0 and output 3. Input A just like input 5 and output 3 just like output. So input is 0, then output is 0. And second condition, if input A is 1, then output will be 0. If input 1, so right click on toggle bit, simply see here input 1 is 1 and input is 0 and output is 0. So save the program. So in this lecture I talked about AND gate, OR gate and NOT gate. So we can write here description. Logic gate, edit comment, logic gate, AND gate, second is logic gate, AND gate, OR gate and NOT gate. So I next
NAND gate or NOR gate. In my earlier lecture, I already discussed about logic gate, AND gate, OR gate and NOT gate. In this video, I discuss about NAND gate or NOT gate. First, I discuss about related to theory, NOT gate, NAND gate and NOR gate. Then theory to combine theory to practical. So let's get started. Okay, so NAND gate. So NAND gate is a gate followed by NOT gate. Easily we can say NAND gate is a opposite of AND gate. NAND gate, in AND gate when added NOT then equal to NAND gate. So Q equal to A dot B or A dot B. So NAND gate, in NAND gate condition, AB as an input, Q as an output. A and B as an input, Q as an output. So in NAND gate truth table, if input A and B 0, A 0, input B 0, then output will be Q 0. If input A 0, input B 1, then output will be 1. If input A 1, input B 0, output then also will be 1. If both input are 1, then output will be 1. Means that if we can see here, if we can observe here, we can observe from here, if any one input, if If any one input is 0, then output will be 1. So let's see the let's check and let's check NAND gate. So right here description, logic gate dash NAND gate. Copy. And second is NAND gate and NOR gate. NOR gate. So let's check condition has been satisfied or not in NAND gate condition. So NAND gate is gate followed by NOT gate. If input A 0, input B 0, then output will be 1. So let's check. Both input are 0, but on that time both input are 1. Both input are 0, on that time both input are 0 because it is a NC. If both input are 0, then output will be 0. Second condition, if input 1 means input A is 0, input B is 1, then output will be 1. If input A is 0, control T, input A is 0, sorry, input A is also always 0, input B is 1, then output will be 1. If input A1, input B0, input A1, input B0, so first I do the input V0 and input A is 1, control T. So output 4 is 1. So last condition of NAND gate is if both input are 1, then output will be 0. So in NC condition, NC is initial 0. When select the toggle, so NC 0 to 1. So last condition is if both input are 0, then output will be, if both input are 1, then output will be 0. So input 6 always, input 6 is 1, input 7 is 1, output 4 is 0. Let's see. Next is NOR gate. So NOR gate is nothing but simple. NOR gate is OR gate followed by NOT gate. X equal to A plus B bar. So in NOR gate condition, input A, input B, output X. If input A is 0, input B is 0, output X is 1. If input A is 0 and input B, input 8 as input A, input 9 as input B. If both input are 0, then output will be 0, right? If both input are 0, then output will be 1. If Next condition, if input A is 1 and input B is 1, sorry, if input A is 0, input B is 1, then output will be 1, because it is connected series, not parallel. So if input A is 1, so my supply left to right, supply going left to right. So left to right supply has been cut from input when supply has been cut when I select input 1, 8 is 1. So output will be 0. If input A is 1, output V is 0. Okay. If input A is 0, then output will be 0. If input 8, if input A 8 is 1, if input A is 1, input B is 1, then output will be 0. Last condition. So if input A is 1, input B is 1, so we can see here easily output is 0. So AND gate, OR gate, AND gate, NOT gate, NAND gate and NOR gate has been completed. Next is universal gate. So in today's lecture we will discuss about some basic example based on NONC. So let's get started. So our first example is here. Input 0, input 1, input 2, input 3. So these are 4 input and output 0, output 1, output 2, output 3. These are 4 output. If input 0 is input 0 in input 0 condition, output 1, output 0, 1, output 1, 0, output 2, 0, output 3, 0. Input 1 condition, output 0 1, output 1 1, output 2 0, output 3 0. Input 2 condition, output 0 1, output 1 1, output 2 1, output 3 1. And input 4 condition, output 0 1, output 1 1, output 2 1, output 3 1. So let's check example in Studio 5000. So bit NONC question based on NONC. So in first condition, input 1, output 0 will be on, output 0 will be on in input 0, input 1, input 2 and input 3. So take a one and no. Take a one and no. And in my earlier lecture, I used input 13 tag. So here input number 14. So first we need to create tag. So click on the tag, controller tag, and select input 14. Data type bool. Copy and paste it. Copy and paste it. Copy and paste it. Copy and paste it here. Copy and paste it here. We can see already tag and sending order. Sorry. Copy and paste it. 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 So we need required output. Output 1, output 9, 10, output 7, output 8. Data type bool for 0 1. Copy and paste, copy and paste, control C, control V, copy paste, copy paste, copy paste, copy paste, copy and paste, paste, copy and paste, copy and paste it here.
So here let's check if in input 1 input 0 condition output 0 will be on, input 1 condition output 0 will be on, input 2 condition output 0 will be on, input 3 condition output 0 will be on. So input 14, input number 14, take a branch and copy the instruction, paste here, copy branch and paste input number 15, input number 16, input number 17, and take a one output y. Next example is when in 4 input, when 4 input, in 4 input, input 0, input 1, input 2, input 3. When input 0, in input 0 condition, input 0, output 0, 1, output 1, 1, output 2, 0, output 3, 0. Input 1, output 1, 1, output 0, output 0, 1, output 1, 1. So we can edit in online program. So next is, if input number 0 is pressed, then output 0 is 0, output 1 is 1, output 0 is 0 and output 1 is 1. Output 0, only two conditions will be on. First is input 0 and input 3. Okay, so edit in let's edit in this program. Output 0 means as an output 8, output 0 as an output 8, so output 8 will be on only input number 0 or input number 3, input number 0 and input number 3. Sorry, delete input number 14 as an input number A, input number 14 as an input number A, input number 17 as an input number 14 as an input number 3A, input number 14 as an input number 0 and input number 17 as an input number 3. First condition is okay. Second condition, output number 1, when output number 1 will be on in input number 0 and input number 1, input number 0, input number 1, input number 0 and input number 1, input number 16 as an input number 1. Second logic is complete. Third condition, second condition is completed. Third condition is output number 2. In output number 2, input number 1 and input number 2, input number 1 and input number 2, in both condition output number 2 is on. Factory Talk Studio Emulator, Factory Talk Studio, Logic Designer. So let's get started. So my previous lecture already created basic programming basic programming logic gate. So in logic gate, first we need to download the program. So click here, RS4 active, and select churches which is want to download. Click the download button. Click on download. 4 error we can see here, 4 error. So let's check
which type of error. Okay, 1 2. So noted here any one rung is empty, so we can see error here. Error search watch. Click on download and download icon. Another use making change the controller cannot the previous process can be request change the complete. Let's check which kind of error showing here. Slot number 1, click on download. Here see ready to download. Studio 5000 Logic Designer software program ready to download to Studio 5000 Logic's emulate. Click on run, minimize, and holding and breaking logic gate, finalize. So create a new run, take a new run, and here first take a new run. So take a new run and no, and tag is 1718. Tag 18 and 1 NC 18 and 19 and 1 output. Take 1 coil for output. Output number 10 11. Sorry, output number 12 because of output number 11 already using. Assume it is a input 18 a LED button and input 19 LED NO button, LED NC button, and output. So I want to on the LED. So right click and click on the toggle. Also Control T. So when we can see here when press the when input 18 the input 18 is in a input 18 is on, then output 12 will be on. But if input 18 will be off, so here my output will be our output will be off. But our requirement when input 18 is off, on to off, so our output will be always on. So what I can do is simple, double click and take a branch, take a one NO, copy output and paste it here, compile. So it is a holding concept, holding and breaking. So click on edit comment, holding and breaking, breaking breaking concept. So let's check when input 18 is on, so our LED 12 is on, but our concern is when input 18 is turned off, then output will be continuous on. So check output 8, sorry, here we can see output 18 is off, but input 18 is off, but output 12 is on. So this kind of method we are using for NONC concept, in NONC concept, holding and breaking condition. So in today's lecture we will discuss about latch and unlatch conditions. In my previous lecture I already discussed about holding and breaking concept. So if you do not watch my previous video, so please visit on my YouTube channel on playlist Basic Studio 5000 Basics Programming, and learn from basic videos to step by step one videos for more understanding. So let's get started. Latch and unlatch concept. So main program, here see interlock concept. Before interlock concept, holding and breaking concept. So in this lecture we will discuss about only latch and unlatch. Simply take a new rung and here click on bit and click on bit, take a one NO and take a latch and take one another rung and take one another NO and unlatch. So I already created tag and use tag from 19 to use tag from 19. So sorry, so input number 19 and it is input number 19 to input number 20 and input number 20 as input and output number already used, output number 13, so output number 13 or output number 14. So it is a latch and unlatch. So I have required two input. For we will doing input number 20 to latch, output number 14, and input number 21 to unlatch, output number 14, same. Here it is must know about latch and unlatch, both are using for same output. So let's download the program in Studio 5000 Logics Emulate. So click on select communication path, and which is already discussed about how to download the Studio 5000 Logic Designer. So click on slot number, and yeah, so Studio 5000 Logics Emulate has been opened the software, and click on download. So download has been start. Let's see here, controlling save recover file, downloading, cancel download. So it is must to know, before download any program, we have must to know verify the controller, because we help to the check any error for any error or not. So here 0 0 error, 1 warning, and 0 error is 0. Here see ready to controller, connect controller, and downloading. Click on download. So again downloading is cancelled. Right click and click on toggle. So we can see when output is latch, when we click on, when we select input number 20 as an input and output number 14 as an LED. So when a select the toggle, when a select the toggle, so output number 14 has been turned on. So here we can see we have not required to latch, we have not required to latch, we have not required to hold the output for holding condition. But here is one more interesting, if I have two inputs, okay, so if I have two input and from one input select unlatch, so what will be happen? If one input select unlatch, so what will be happen? So when I select first unlatch, so what will be happen? And after select unlatch, I have required to latch, but when we select unlatch condition, so we cannot do able to the latch. Why? Because output already latched, output is already latched. So for this reason we cannot able to the latch from input number 20. Example, but if input number 21 unlatched, so easily output number 14 is latched. So thank you for watching my videos. If you learn from my videos, so please hit the like button and subscribe my YouTube channel. and share your friends for better understanding. And next, if you have any topic related to Studio 5000, Factory Talk Views, and Factory Talk View tools, any query, so please comment on my comment box. And if you sorry, if you required any interview books or interview content, sorry, if you required interview question answer PPT, so please comment in comment box. And thank you for watching my videos, and have a great day. We will discuss the different type of timer available in Studio 5000 Logic Designer software. So how to use them. So here click on logic organization main program, and click on main program, and already all program we have our all program in main program. So just let's start how so first take look basic type of operation timer in Allen Bradley. Basic type of timer in Allen Bradley. Take a new run operation, and different type of timer. Studio 5000 Logic Designer for the software provide the different type of timer, like we can see here: T on timer, T off timer, and RTO timer. T on timer also we can say timer on. T off timer also we can say timer off, and RTO timer also we can say retentive timer. So we will review and this difference between these timer and show you how program them in the software. If you new Studio 5000 programming software, this video will be provided to comprehensive overview than different type of timer available on the create timing operation. So let's get started. So timer are very useful common function in Studio 5000. Allow you can control timing and sequence event. Timers are very useful and common function in PLC programming. They allow you to control the timing and sequence of event in your logic. For example, you can use timer on delay, or we can say T on timer, the start stop motor function, or create a blinking LED, measure the duration of process. Studio 5000 in Studio 5000 three types of timer we can see here: timer on, timer off, and RTO also RTO timer. So let's start from timer on. So timer on, take a bit new take a new empty operand, and here write T timer underscore on, and create a new tag. Timer on 1, control W, and here write a timer name, any name of your timer, just like timer underscore on. Timer underscore on, and you create a new tag. And here
the use controller type base data type timer. Okay and okay. So Studio 5000 timer used in Studio 5 timer in Studio 5000 timer use different type of timers. The timer of provide consists of 5 individual tags. So first is enable bool tag en. This bit true whenever timer instruction is active, no matter how much time has elapsed. And second is timer timing bit, or we can say TT bit. So this bit is true when the timer is actively performing the timing operation. Done bit bits bool data types of bool, these are 5 bits. So true when the timer is actively performing the timing operation. Done bit, the timer bit goes true when the timer has counter. When done bit, this bit goes true when the timer has counted up to the reach it preset value. Means that when timer is completed the timer timing bit after preset value, and preset value equal to accumulator value, means accumulate value on that time timer done bit has been on. And preset value, this is input allowed to set timer for preset value. It is a preset value. This is an input that allow you can set timer for how long last before completion. The unit of present millisecond. So if you want to timer for 10 seconds, you need enter the 10,000 as the preset value. Means that in Studio 5000 timer preset value take in millisecond. So 1 millisecond is equal to 1000 second. So if our requirement to 10 seconds, so 10 into 1000 millisecond equal to 10,000 millisecond. So accumulator and preset value, these both bits, accumulator and preset, these bits is dint. Accumulator value, this show the high the time is in its current count. It also has unit. Accumulator value, this show you high timers in this current count. It is also unit of millisecond. So let's write a example. 5000 timer, 5 second means 50 second. 50 second means 50 second means once, tens, 100,000, 10,000. And take a new rung, take an NO and one another output, copy and paste it, and copy and paste it. So here timer, you can select from here en bit, copy, paste and copy. En bit, TT bit, last it, done bit. So example LED 1, LED underscore 1, and LED 2 underscore LED 2, and also LED 3. LED 3. So control W, create a new tag, control W and control W. So let's so we have required a comment. So here write a comment T timer timer / timer on, or we can write T on. So click on download and select the Studio 5000 Logix Embedded Programming. Click on download. Click on emulator and select the run. So first we need to on the timers from control T. So we can see here LED 1 is on, LED 2 is on. LED 1 when timer is on, when T on timer is on, also when T on timer is on, then timer on TT bit is energized. Here we can see LED 1 and LED 2 both are LED has been on, and when timer on will be completed, reset value equal to accumulator, then done bit has been on. We can so observe here done bit has been on and already timer enable bit already on, means because timer is provide continuous value, timer on required continuous value. Example, timer on is we can cut the supply of timer on. Example, we again observe here timing has been start 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 13, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. So when preset value equal to the accumulator value, then done bit is on, and when done bit is on, LED 3 has been on, and timer timing bit is off. Why? Because when I already talked about when preset value is running, on that time timer timing bit is on. When preset value equal to the accumulator value, timer timing bit off. So if we have required to turn on LED 1, LED 2, so if we have required turn off LED 1 and LED 2, so click on toggle cut the supply of timer on. So LED 1, LED 2, LED 3, all these timer LEDs is off. So if we have required to reset the timer, so take a reset bit, finalize. So again, once again try to check that this T-on timer is reset or not. So observe here, when done bit is completed, because T-on timer is run in millisecond, so you think millisecond is very small times. So when T-on timer done bit is completed, then NO, NC to NO, and then when NC to NO, timer on supply has been cut and timer will be reset, and when timer will be reset, again done bit is 0. When done bit is 0, then timer done bit NC to NO to again NC, switch from again NC to NO to NC. So click again toggle and absorb. We can see when timer has been completed the time, then again done bit, when done bit is on, timer has been reset. Observe again, you also try and observe once again and again. So here T off, control W and T timer underscore off underscore 1, control W. So first introduce timer off. What is the timer off? So the timer off delay instruction work of oppositely it start the timer when input condition goes from true or false. The timer then count up until reach the preset value. In timer on, when timer is on, then start the preset value, but in timer off is totally different of timer on. When timer on bit on, then preset value. When timer on bit off, then true to false, then preset value has been start for counting. Timer count until it reach the preset value and then set the done bit to true. Timer stop counting when the input condition goes true, reset and accumulator value to 0. So we will check our timer how to work. So take another rung and another rung. So also we have required one bit and one another bit and one another bit. One input timer TT, timer off, enable bit, and LED 1, LED 3, LED 4, and control W, copy, paste, timer on, enable bit, timer off, TT bit, and timer off, done bit. And finalize the program, initialize and start. Here we when see kilometer value example 40 seconds, once, 10, 100, 1000, 10,000. So in initial condition timer off is off. In initial condition timer off bit is off. So click on right click, then toggle. We can observe very easily timer off enable bit is on because in timer off continuous supply, and timer done bit is on. It is totally opposite of timer off, timer on. In timer on, when complete the timing preset value to accumulator value, then timer on, then timer done bit is on. But in case of timer off, when start the supply of, when goes that supply of timer off, then initially enable bit and initially done bit is start. But in case of timer on, when on timer, then TT bit and timer off bit, TT bit and enable bit start of on. So only one difference, two difference when continuous supply goes from timer 1 to timer off, then timer off enable bit on, sorry, LED 5. So just so right click and off the supply of timer off. Click on toggle bit. We can see when timer of supply has been go, so timing bit is start, also timer 1 minute, sorry, to timer so again we observe when timer off, then LED number 4 is on, LED number 6 is on. When timer is off, toggle bit. Here we can see what is the condition of your cursor. See easily. So cursor on toggle. So here we can see toggle the bit value of the tab. So toggle and timer has been off. So start the counting accumulator to preset value. So on that time timer TT bit is on and done bit always on. When timer complete the timing bit, timer of preset value equal to accumulator value, on that time LED timer done bit is off, also timer timing bit on off. (32, 33, 35, 36, 37, 38, 39, 40). So one more advantage of timer off. So timer off, we have not required to reset of timer. Retentive timer. So take a new run. So timer RTO timer means retentive timer, also just like a T-on timer, but a retentive timer when supply goes from timer off, retentive timer when supply goes, so timer is retain the value. Timer RTO, control W, and timer RTO timer base bool basic programming, and here write a timer RTO timer. Copy and paste it here. Also change timer timer RTO to paste UN bit, TT bit, and last is we can also from take bit from here, LED number 7, LED number 8, and also LED number 9. So control W and control W, control W, and finalize. So let's check of function of RTO timer. So when click on RTO timer 1 toggle bit, so sorry, we have not take a timer off. Example, timer RTO timer preset value is 20 seconds, 1, 10, 100, 1000, 10,000. So why we take 10,000 in timer or RTO timer? Because of RTO timer is written, because of in Studio 5000 Logic Designer is read a value of timer in millisecond. So 1 millisecond equal to 1000 millisecond, and we example we have required 20 milliseconds, so 20 seconds, so 20 into 1000 millisecond, so 10,000 millisecond means 20,000 millisecond. So click on toggle and start. We will see what happened. So let's check off RTO timer. So the RTO timer of delay, T on delay, RTO retentive timer, just similar a timer on. RTO timer just like a T on timer, but in RTO timer when supply is cut on uh, when start preset value, on that time example supply will be cut. You can see timer accumulator value is accumulator counting is start 10, 11, 12. Observe here when timer example in RTO timer we can see here when timer is complete then enable bit and done bit is on according to T on timer. But here in timer uh, just like a T on timer. So again timer on and so first we need to reset timer on, go offline, go online. So take 20 seconds. Preset value is 20 seconds. Timer RTO timer is on. Here we easily absorb when RTO timer is running. So I cut the supply of RTO timer. On that time RTO timer accumulator value is hold, but in case of T on timer it is not possible because it is a property of RTO timer. So click on toggle So we can see here timer timing is start 3, 4, 5 seconds, 6, 7, 8, 9, 10. So here easily when timer is off, RTO timer supply is off, so timer accumulator value is hold, but in case of T-on timer it is not possible. Also we discussed just I discussed. So when again timer is on, then continuous when continuous again again calculate that again start the timer of RTO. So this timer we can use in function just like when our motor is running 1 hour. After 1 hour motor is stop. Example, our motor is start running at 1 hour from start time. After 1 hour motor is stop. So again when motor is again start on, we have required to how many hour motor is start. We have required how many hour motor is run. So when again run the motor, so on that time we can use the RTO timer. So calculate the value from stop to start, stop to start, stop to start, again. And example, after 10,000 after 10,000 hour we have required to reset RTO timer. So we can easily reset the RTO timer just like a T off timer. So we easily the reset with the help using NC of RTO timer. Done with. So it is only 2 seconds. So start and 1, 2, timer is reset, but done bit is already high, done bit already on. So our requirement is done bit is reset. So how to reset the done bit, because timer of T off timer is hold. So we can take a NC. We take a NC of timer on enable bit. SIO. Sorry. SIC. So when timer is complete, done bit is on, but our LED is off. Or we can use reset button for the off LED. So I hope this video was helpful and you learned something new about timer in Studio 5000. So thank you. Here we have two counters. Both counter will be controlled by individual input. So two counter, both counter controlled by individual input. First, so take a new run and here write another input bit xio, and how many input I already used, input 31, so its input name 32, input underscore 32, and input 32. Right click and click on new tab, create a new tab and take a counter up, and first counter is completed. Both counter will be controlled by individual value. Counter 1, so counter 1 name is counter 1, counter 1, and same copy and paste it. Second name input number 33 and counter 2, and control W, also control W. We can define tag by control W or right click and new, create a new tag, also control W. So one step is completed. Okay, next is our requirement is if the counter is first value, requirement is if counter first value, sorry it is wrong, if counter first value is 10 and counter second value is 20. Okay, counter first value is 10 and counter second value is 20. Counter second value is 20. If both combination of counter value is 30, both combination counter value is 30, then LED will be on. So how it is possible? So it is possible with using add block. So click on compute mathematical, and from before take a new run and select the add counter 1. If counter 1 value is 10, counter 1 and counter 2. So counter 1 and counter 2 value is 30. If the combination of counter value is 30, then LED will be on. So counter A accumulator value and counter B accumulator value, both counter accumulator value will be add. And if counter, both counter estimator value is equal to 30. Add, right click, okay. If both counter value will be equal 30, then output will be on. So take one output energize. So our last LED value is 16. So LED number 17. This is LED number 17. And right click, create. So our program is ready. Let's check what will be happen. And before download, our requirement is verify controller, and open the software of Studio 5000 emulator. So click on communication, RSO. Who is active? So active is one Studio 5000 Logic emulate basic program. Click on download. Click on download. Communication timeout. So let's again check. Click on download. What will be error? What is the error? Controller is not correct mode. So I think controller is in. So let's check what will be happen. Why download not download of the program? So controller is fault mode. So anyway, when your controller Studio 5000 emulate has been go fault mode, so simply right click on the particular controller which is you are used and click on clear fault, or we can remove. So clear fault, right click, who active, and again click on download. So after compile, again click on communication and who active, select the hardware emulator and click on download. So let's check what will be happening again.
select download. So program is downloading, linking, routing, structure, text, basic program, main program. Finalizing download. So if that type of error anyway, that type of error when you have faced, so simply compile and again down select the communication path and download your program. But the program is select program, remote mode to run mode. So what is our question is if counter 1 first value is 10 and the second counter value is 20. If combination of counter both value is 30, then LED will be on. So our both combination value is 30 when then LED will be on. So here if counter 1 value is 10, 1, 2, 3, so counter 1 value will be 10. Counter 1 value has been 10 and let's counter 2 start the counting. 1, 2, 3, 10, 7, 17 and 17. Total value is 17. Total value is 17. Value is continue adding. 12, next 13, next 14, next 15, next 16, next 17, next. Please we can observe easily our value is 28. Sorry, our value is counter 2, counter 1 value is already 10, counter 2 value is 20, preset value 20 and accumulator value 18. So when counter 1 and counter 2 both counter values add 28. So counter 28 and you can see 29, 30. When both counter value, first counter is 10, second counter is 20, so both values add 30 and when 30 is reached
then output will be on. So our first problem has been solved based on it problem based on counter its problem based on equal block and add block. Second,
So hello everyone, welcome back to my YouTube channel KS Automation. So in this video we will discuss about how to use mathematical multiple block with compare blocks and also with counter block. I already discussed about in my previous video how to use timer, how to use counter, how to use NONC interlocks, and how to use how to make LED blinking. So if you new in my videos, so I recommend you please go my playlist, go on my YouTube channel playlist. So please visit on my YouTube channel playlist, that is the name of basic Studio 5000 basic training, and watch step by step one by one videos for your better understanding. So let's see how to use compare block and with using counter. So we can solve a one example. We will solve. So let's get started. So what is the example or what is the problem here? Here we have two counter. We have two counter with both counter will be controlled by individual individual digital input. Our requirement is if counter first value will be 20 and counter second value will be 10, if both counter combination value will be 200, then LED will be on. So let's see how it will be possible with using multiple and also multiple and also compare blocks. So here we have I already make the input number. I already discussed about how to use mathematical block. I already discussed about how to use subtract block and also add block with using counter and compare. So in this video only discuss about how to use multiple block with using counter. So we can see it is a subtract block, it is a previous lecture. So we have two counters. So counter 1 value will be 200 from question. Counter 1 value first value will be 20. Counter one first value will be 20. So counter 1 preset value will be 20 and counter 2 21, and if counter value will be 21, then counter will be reset. So why I will reset it is it counter, I discuss about after some time. So counter accumulator value, second counter value will be 10, and second counter if 11, second counter value will be 11 equal to 11, then counter will be reset. So from here change add to subtract block. So easily if you want to change add to subtract block, so we can drag and drop from here, compute math from here, multiple block easily drag and drop here, easily drop here. Also we can or we can do from here, right click on subtract block, one click and double click of from the mouse and select the this icon, and then after that select multiple. So if both counter value 1 accumulator and counter value 2 accumulator value, both counter accumulator value multiple, so from destination change destination multiple, MUL multi, if both combination value change, so 1 and 2 multiple block, LED number 7 will be on. So communication block, select RSU, and here we can see our default path Studio 5000 Logic Emulator 5. Click on download. Always remember when your program has been completed, so before downloading, compile and finalize your program. So our program has been downloaded, so we can select PLC mode, remote program mode, and also remote run mode. We can select run mode or also text mode. So now I will select run mode. So right click, select the change controller mode to run mode. Click on yes. So yeah, why we use equal block, and why I can reset the block, for reason is when counter value is first counter value is 20 and if second counter value is 10, so both counter value is combination 20 combination, both counter combination value will be multiply, then LED will be on. If first counter value will be 11 and second counter value will be 12, so it is not possible of both counter combination value is 200. So let's see, before start the counting of counter, select the value of counter is 0 and also second counter. So now right click and click on toggle, also second counter to input, second counter to input, right click and second click on toggle. So now we will start. Now we can start. So simply right click and select toggle. So we can see here counter 1 value is 1, and again right click, second again toggle, right click and second again toggle. Also from right click we can do cut, copy, paste, delete instruction, add element, edit, main operand, description, toggle, force on, force off, go to instruction mode.
So our counter value is 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 13, 14, 15, 16, 17, 18, 19 and 20. So if again select toggle, so our value counter value is go to 21, 20 to 21, goes 20 to 21. So now counter will be has been reset. So for this reason I used a counter from counter accumulator 21 to reset, and second counter value will be 10. So start from 0 to 1 and 2. Please observe here. Please observe here. 1 minute. So 1, 2, 3, 4, 5, 3, 4, 5, 6, 7, 8, 9, 10. So we can see counter value is 10. First counter value is 20 and also second counter value is 10. So both counter value combination value is 20. But LED is not on. So why LED is not on? So what will be happen? I think we can use double output. Yes. So I have required to delete first output. Last output. We cannot use output 2. We can only use one output. We can use input multiple times, but we cannot use output multiple times. Output we can use output only one times. But output use as a input multiple times, but output we cannot use multiple times. Output only we can use one times, not multiple times. It is always remember when we are using Studio 5000 software. So it is always remember. So we can see here LED is on, and if counter value is overflow means counter value will be going from 10 to 11. So counter has been reset. Counter is reset, and when counter is reset value is 20. So 20 to 100 not equal to the 20. So condition is not satisfied. For this reason LED is off. So thank you for watching this video. If you learn from my video, also if you like from my video, so please hit the like button and subscribe my YouTube channel for never miss update, and please also share
for your friends, so easy to learn industrial automation from basic to advanced. It is my promise, and it is my so for your friends, share from your friends to learn basic to advanced ISA 88 based industrial automation from basic to advanced. So thank you, have a great day, nice day, keep learning and keep going. Basic, and also please keep keep practice, because without practice nothing is perfect. We cannot perfect in any field without practice. I don't know any field, but we from my experience we cannot perfect uh, in industrial automation without practice. So see.
To my YouTube channel PS Automation. In today's lecture, I discuss about compare block in Studio 5000. What is compare block? Type of compare block? How use compare block? So, if you new on my YouTube channel and if you beginner related to PLC programming, if you beginner on PLC programming Rockwell platform Studio 5000, so I recommend you please visit on my YouTube channel playlist that is uploaded on my YouTube channel. Playlist name is Studio 5000 for beginner for your better understanding. So let's get started. So I already uploaded my videos, mathematical block, timer. I already upload on my YouTube channel video related mathematical block, timer, counter, compare, mathematical block, timer block, counter block, reset, all other instructions. So in this video I discuss about only compare block. What is compare block and how to use compare block. So here is a what is compare block. From you can observe a name compare. When we have required to another value compare, when we have required compare to another value, values come from the field. Example, temperature to another temperature transmitter, level transmitter, both transmitter value coming from the field. So if required to compare both transmitters, so on that case we use compare block. So how many type of compare block? So here is a compare block: less than, greater than, less than, greater than, equal, less than, equal, greater than, less than, not equal, equal, max equal, limit, and CPT. Video only discuss two type of block: equal and greater than equal. Sorry, in this video I discuss only two type of block: greater than and greater than equal. So let's see how to use with counter or timer. We can use from counter and also we use from timer. In compare we can use timer, counter. Start how to use compare block. So take a counter and take a bit and take a counter. Here you can write input. I already created input number 31 to 1 to 33. So now select the input number 32 and counter1. Okay, counter1 input, and write here name is counter1, counter slash compare 1, and write value is 20, and take a one another rung and take compare greater than, compare greater than, and take another rung, compare greater than equal, take a bit output, take another bit output, and write here name greater than. When a is greater than b, a means counter 1. When counter 120 value is dot accelerometer value 20 value is greater than 18, then LED example LED number 15 will be on, and when value is greater than equal, greater than equal 15, greater than and also equal 15, then LED number 17 will be on. Before check cross reference. Okay, so we need to save, and before download always required. So controller is program, change controller program mode back to run mode, click on program back, remote program mode to remote run mode. So now controller counter value is 0. So before starting, observe when counter greater than, counter compare 1 value is 0. Now counter compare 1 value is 0. When counter compare 1 value is greater than 18, then only that on that time LED 15 will be on. And also next is greater than equal, when counter compare value is greater than also equal 15, then LED will be on. Means that when any situation, that situation is required to greater than a specified value from the when required a specified value greater than output, required output will be on, required output should be on. And when greater than and also equal, situation is greater than also equal, and output should be required should be output on, then we can use greater than and equal both block, greater than and equal instruction, and only greater than instruction when required output, when should be output only greater than and equal, only greater than from another value. So start, we can control right click and T, and also control T. One, two, three, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and 18. So we can absorb now 17 value, a value greater than from the b. B value is 15, a value is 17. So counter value is greater than 15 value. For this reason output will be LED 17 is on. Greater than also equal. Next is 18. So why LED 15 is not on? I think output is we have used double. No, it's not double. Greater than, when counter compare 1 greater than counter value, then LED 16 will be on. So 18 now greater than 19. We can see output is on. So thank you for watching my video. If you learn and if you like of my video, so please hit the like button and subscribe my YouTube channel for never miss. So hello everyone, welcome back to my YouTube channel PLC Automation. So today lecture I discuss about compare block less than and greater less than equal. We can see, you can see in my previous lecture I already discussed, you can see in my previous video I already talking about, I already discussed about greater than and also greater than equal. So in this video I discuss about less than and less than equal. So what is the less than? Less than means any other value or any value, source A value required less than source from source B. So our requirement output will be on, output should on when source A should be, when source A less than should be less than source B, then should be LED will be on. Example. So let's check how it is possible and how it is work. So nothing will be changed in greater than to less than equal, less than equal and less than, and from here greater than equal to less than equal. So when and counter 1 value is 0, counter 1, counter compare value will be 0. So when A is less than 18, change the value 18 to 15 and 18 to 12 or 18 to 12, 15 to 18. So when A is less than 15 means that condition will be 2. So LED 16 should be on, and when A is less than also equal is 15, then LED 17 should be on. So save, click on save button and compile communication RF2 and click on download.
And in this case, when if less than is less than value, if counter compare value is greater than 15, so LED should be off, and counter compare value is greater than equal cannot communicate RS link communication software taken offline. If offline progress will be not complete, will be result lost. So compare. Okay. Click on remove. Required again. Select the Studio 5000 emulator. Click on create. Select from here module type emulator 5570. By default slot number 5. Version 33. Starter mode. Last controller mode. We can set memory from 0 to 67 MB. Next, EQ continuous task is 5 milliseconds. Sorry, 50 milliseconds. Click on finish, and yes, program has been downloaded. Click on change controller mode by current mode and start. We can see here now counter value is compare counter value is say A is less than B, or we can say A is B is greater than A. Again, we can say A is less than B. Also, we can say B is greater than A. Same for greater than less than equal. We can say A is less than equal B, and we can say B is greater than equal A. So now greater than A. So now B is greater than A means A is less than B. Now A is less than B, condition is true. For that reason LED should be on. So LED should be on, and when less than equal B, so LED 17 should be on. So let A is greater than B. When A is greater than B, so what will be happen? Start 1. Also, when A is greater than B, or we can say B is less than A, so what will be happen? Select 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 9, 10, 11, 12. We can change the value. Next value is 18, and like
11, 12, 13, 14, 16. So what will be happen? We can say now A is not less than B. Now A is equal to the B. 15. A 15, LED should off. So for this reason LED is off. Next is for less than and greater than. 16, 17, 18. We can observe now A is less than and greater than B. Counter value is 18, set value is 18. So at time both values equal. If counter compare 1, if value is greater than 18, so LED should be off. Let's check. 18, 19. So we can see counter compare 20 value is greater than 18, and means that compare less A is less than equal B. Not true. A is greater than is B from B. So for that reason condition is not true. For that reason LED is off. So thank you for watching my video. If you learn and if you like of my video, so please hit the like button and subscribe my YouTube channel for never. So hello everyone, welcome back to my YouTube channel PLC Automation. So in today's lecture I discuss about CPT block and also not equal block and also equal block. In my previous lecture I already discussed and make video on less than equal, greater than equal. You can see it is my last video. So if you new on my YouTube channel, so please I recommend you for better understanding and better learning, visit on my YouTube channel playlist that is uploaded on my YouTube channel PLC Automation. That is playlist name is Studio 5000 for beginner. So for your better understanding, so let's start how to use CPT block and what is CPT block and how to use them. So take CPT first, equal and not equal. So equal block and one another is a not equal block. So not equal. And from previous video I already made the counter. So copy and paste it here. We can write anything value 60, 80, 20 in under 20 because counter value is 20 and 30. Next is our require is counter reset. Also greater than. When A is greater than 20, so required counter will be reset.
copy, and counter accumulator value placed, counter accumulator value placed, and click on save button. Before download the program, always required to verify the controller, also required verify routine. When you click verify controller, so in all program any error, so easily we can easily see here error. So now is a complete zero error and zero warning. And when say click on verify routine, so from we can see only routine error. Select communication RSO, already by default slot number 5, and basic means already talked. Basic means Studio 5000 slot basic 5, model is basic slot 5. Click on download. Warning, structure test routine cannot be reached by the main routine. So program is main. Okay, that's right. Required the structure test routine is main routine. I talked about this related to topic structure test, how to program structure test, how to I am in structure test language, means ST language, and also when start the video, when start the course on IS-88, so already on that time discuss about structure test, because structure test used in IS-88 programming, not normal programming. We can use normal programming, but in normal case not use structure test in normal programming. So for that's why I'm not talking about structure test in this video. When anyway, so in the first case, if counter accumulator value is equal to the source V, so in this case LED will be on, otherwise LED will be off. Only equal to the source B, and in second case not equal when counter value will be not equal to the 15, only in this case LED will be on. So now we can see counter value is 0, so counter value 0, so source B value is not equal to counter accumulator value. So for that reason condition is true, for that reason LED is on. And in first case, if in first case counter accumulator value is not equal to the 16, so LED is off. So start when, now we will start the counter from 0 to 20, and let's see what will be happen when counter value reach 16 and when counter value reach near 50. So control and T toggle, control T toggle, 1 2 3 4 4 5, 6, 7, 8, 9, 10, 11, 12, 13, 15, 14 and 15. We can see not equal is not true because 15 is equal. Source V counter compare one accumulator. So LED is off, and when next when accumulator value counter accumulator value 16, so what will be happen? We can see counter accumulator value is now 16, means counter accumulator value 16 is equal to source V 16, so LED 16 is on and not equal to the counter accumulator value 16, so LED is on. In not equal, counter compare value is 16 and source V is 15, so only when in not equal case, when source A is not equal to source B, not counter, timer, timer or counter on limit block value, any value. So when source A is not equal to source B, in this case output will be not on. When source A is not equal to the source B, in this case output will be on, and when source A is equal to the source B, then output will be on, off. Or we can say, or we can observe, when source V is when source A value is greater than or less than source V, in not equal, when source A is greater than or less than from source V, in this case LED will be on. And in equal, when source A is not greater than and not less than source V, means only equal, then LED will, then output will will be on. So thank you for watching my video.
So hello everyone, welcome back to my YouTube channel KS Automation. So I am very happy to share my knowledge on Rockwell platform in Studio 5000. So I hope you are enjoy this journey, learning journey from zero to advanced, basic to advanced. So in this video I am discuss about how to use move block and move logical instruction, move block and also block and instruction, bit with in exclusive OR and bit with exclusive NAND. And so let's check how to use. First we will see how to use move block, and then we will see how to use add block, and after that then we will see how to use OR block. So let's so what is move block? Move block is nothing but with the help move block we can move value from another move value from another output to another input, or another input to another output. Just like take example, we have take example, take a timer, and timer name is move TMR, and right click on move TMR and click on create, and after that take a move block, logical, move logical, take a move block, and after that take another LED, or take another move block, and we have a counter, compare logical. We will take a counter, timer counter, copy and paste, and delete instruction, and take another instruction run, and click on on timer, and delete, fill on to counter up, and delete on timer from run number 31. So we have required, we have to move block. So, and from move block also take a multiple block, multiple. So we know that in on timer preset value required for 1 second 1000 millisecond, because on timer in Studio 5000 on timer value read in millisecond 1 second. When we have required to put value 1 second, so we will put value 1000 millisecond for 1 second. So the name of timer move TMR, and here multiple move MUL, move MUL, base, create controller base, and by default data type dint, scope programming, external source decimal, consume and sequencing, open instruction logic. Click on create. Source A to source V 1000, and move TMR, move TMR dot move dot move TMR dot 1. Control T, Control W. We require copy and paste it here. Move and for destination, click on right click on timer, copy and select on move, paste it here, dot preset, and for second move
move counter, move counter, and control W, and right click, move. So now we can see program is finalizing. Program has been finalized. Done download, change controller mode back to run mode. Click on yes. So from easier we can use for simplification change millisecond we can use this method for change millisecond into minute, or we have required to change hour. So click on add a one multiple block and into 60, because 1 minute is equal to 60 minute is equal to 1 hour. So 60 minute into 60 minute is equal to 1 hour. So 60 second, it is a 60 second. 1 minute 60 second, 60 into 60, so 36 minute means 1 hour, and 36 into 1000, so 33 lakh millisecond equal to 1000. So click on multiple block and we can change the block 1 to 2 minutes. Easily we can see change 1 to 2 minutes. 2 into 60, 1 2 into 60, 1000, 1 lakh 20,000, and 1 lakh 20,000. LED will be on. LED is on till now until in unless till LED is on till now, timer will be complete done bit, and after done bit timer has been reset. Timer will be reset. Click on save. Also we can check for counter. So control T, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. We can see 15. Now timer accumulator value is 15, and done timer done bit, timer done bit, and LED 23 is on. Example, we have required to change preset value of the counter. So we set CPU dash TRE dash 1, control W, right here, from here 20. So we can see easily value is moving from move block C2 PR preset 1 to move CTU preset. We can see move 20 and LED will be off because I just change the value. So thank you for watching my video. If you learned and if you like my video, so please hit the like button and subscribe my YouTube channel. Thank you. Have a great day. Keep learning, keep going. Welcome back to my YouTube channel, PS Automation. So in this video I discuss about how to use add and block, how to use logic gates in blocks, and block, and logic gate, AND gate, OR gate, NOT gate, and also XOR gate. In my previous video I already discussed about mathematical logical blocks and also compare block, limit block, timer, counter, alarms, bits, and also I already cover in my previous videos how what is logic gate and how to use logic gate. But in this video I discuss about logic gate block, how to use logic gate block. So we does not require any right logic gate, we can use easily logic gate block. So let's get started. Take a new rung and after that take a NO, examine on XIO. So here tag name is will be logic gate 1, sorry gate 1, gate underscore 1. Gate 1, right click and click on new and click on create and take a logic gate block. So logic gate block in the sequence and shift logical move logical operation. Select here AND gate. So let's see how to use AND gate. So here tag name source A and source B. We know that I already discussed about logic gate, how to use logic gate, source A and source B, and how to work logic gate. But in this video this video only based on logic gate block. And one tag will be and 1 and right click, copy and also create. And 2, right click, click on new tag and click on create. Explanation will be example when two value will be equal, when value 1, example temperature transmitter, example any transmitter value will be in normal case in logic and gate, logic gate we know that if both value will be 0 then output will be 0. If value 1 will be 1 and value 2 means source A will be 1, source B will be 0, then output will be 0. If source 1 will be 0, source B will be 1, then output will be 1. If both condition will be 1, then output will be 1. It is a normal condition of AND gate. But what is the difference of AND gate with using NO and C, and what is difference between AND gate block? So let's see. It is a very interesting or very useful block, AND gate. So take another rung, copy, and here paste, and cut rung. Take another rung and take a limit block, copy output, limit text, and 1, 10, 1 output, and LED number 23 already used, so copy and 24, LED number 24. So what will be happen here when LED, let's see what will be happening. So shape, it is very interesting, so please, for your better understanding, keep watching your start to end video. Click on download. It's very interesting. So we all already know that what is AND gate, so I don't discuss about on AND gate. Don't waste your time, our time. So let's see. In initial condition, both source A and source B, both value is 0. If source 1 value will be 0 and source B value will be 1, so output will be 1. It is a fundamental condition of the AND gate. If source B will be 0 and source A will be 1, then output will be 1. Also fundamental condition of the AND gate. If both condition will be 1, then output will be 1. So let's see here, limit 1 to 10. So what is means that limit 1 to 10? Why I take limit 10? What is the reason? So reason is, in AND gate, it is very interesting. In AND gate block, if source B value is 2, if source B value will be 2, sorry, source A value will be 2 and also source B value will be 2, sorry, 3, also sorry 1. So what will be happening? Destination means that output will be 0. If source A will be 2 and source B will be 2, so what will be happening? Destination in limit 1 to 10. So 1 to 10, 2 value is under 1 to 10. So for that reason LED 24 is on. So where we can use AND gate, example, A is 1, sorry, if source A is 1 and source B is 0, then output 0 definitely. If source B will be is 1, source A is 1, source B is 1, then output is 1, because 1 or 1 in AND gate, 1 or on 1. Here understand. Next is, what will be happen if source B value will be 2. So 1 to 0. So this is a here you can see source A, destination, and output. Source A will be 2 when source if source A is 1, so destination output will be on, LED will be on. When will be LED on? After one when destination greater than 1 one number on and one number off, means one on when output, when source V will be 1, then output is on. When source B will be 3, then output will be 1. Observe, when source V will be 4, then output will be off. Source V will be 5, output on. 6 off, 7 on, 8 off, 9 on, 10 off. I think you easily observe, after one value, so when source B greater, after one, after one, after one, after one, after one, so one on and another next value on, next value is off. On when reach next value source V, then output will be off. Let's see what will be happen when source V will be 2. So same condition, source, when source V will be 2, so after 2 source, when source A will be 2, so after 2 condition, 2 number output will be on and 2 number output will be off. So let's see how. 1 0, let's, and 2 2 to 1, right? 2 and 2 1, because 2 and 2 value will be 2. Let's see 3 on, right? 2 number on, 4 off, 5 off, 2 number off, 2 number on, 6 on, LED on, under limit under 1 to 11, 7 on, 8 off, 9 on, 10, sorry, 9 off, 10 on, 11 on. Let's next example. This is a table created by myself just. Next is, what will be happen when input source A will be 1, sorry, source A will be 3. So after 3, when source A is 1, so after gap, 1 gap, source B 1 gap, output will be on. 2 on, source B 3 on, source B 4 off, because 1 2 3 in condition 1 and in condition 1 2 3, in 1 2 3 condition output is on, and 4 5 6 output will be off. 4 5, sorry, after 3 condition output will be on. 5 on, 6 on, 7 on, 8 off. When source B will be 8, output will be off. 9 on, 10 output will be on, 11 output will be on. Next, if source A is 4, so I think you easily understand the concept of AND gate. AND gate, not AND gate, bit bitwise AND, not AND gate. It is a bitwise AND. example, source A is 4, so 1 0 2 0 3 0 4 1 5 0 sorry 1 6 1, so 5 6 4 5 6 7. In 4 number output will be on. Seven, 8, 4 5 6 7, 8 of 8 of 9 10 11, 8 9 10 11, in on 11 on output. Next, if output will be 12 on, how? Okay, because output 4, output 13, output 14, output 15, source B 16, source B 16 17, 18, 19, 20 on. I think you can absorb easily after every after 4 number of gap. After every 4 number output will on, output is on and output is off, same as it is, same condition for 5. If source A will be 5, same condition source B A will be 6 7 8 9 10. If you want to, you can text or easily absorb, or you can see how to is work. So next gate is
bits with bitwise instruction in Studio 5000. I already discussed about how to use what is and bitwise and how to use and bitwise instruction in Studio 5000. If you new on my YouTube channel, or if you beginner, so I recommend you, please, I suggest you, please go on my YouTube channel that is uploaded on my YouTube channel, PS Automation playlist Studio 5000 for beginner, and watch step by step video for your better understanding. So let's get started. So take a new rung and click on logical move instruction and OR gate or bitwise exclusive OR, and take a move block for move value in OR source A and also OR source B. To move block for OR source A and OR source B, and tag name will be OR1 and second tag will be OR2, and copy and paste it here. Sorry, paste it here, and move or move or underscore
move 1 and copy paste it for second source or move 2 and destination will be or move 2 and final destination or out or underscore out. Take another run and take limit block, limit compare block in limit. Example 1 to 50 and out limit text will be paste and take a bit I will take a bit and output energize. Tag name will be LED 25 because already used LED 24. So new tag name LED 25. So let's finalize and click on communication RSO and download. Now our program has been downloading. Click on download. So exclusive bitwise exclusive or only read value. We know that fundamental condition of the OR gate is 0 0 0 or 0 0 0 or 1 1. You know that fundamental condition of OR gate 0 1 1. Move 1 destination or 1 and 0 1 1 limit 0 to 15. For that reason under the 15 1 LED number 25 has been on and 1 0 0 1 0 1 0 1 also 0 1 1 limit under limit 1 to 15. For that reason LED 25 has been on and 1 1 1 move 1 or 1 we can see move value 1 in OR gate bitwise OR gate and move value 2 also bitwise OR gate 2 or 2. So 1 1 1 and 1 under 15. So LED will be on. Example or move 1 value will be 2. So what will be happening? 2 1 3. LED will be on. Example 3. What will be happening? So output will be 3 and LED number 3. LED will be on. For example 4. What will be happening? 5 4 1 5 LED will be on. So if bitwise value in bitwise value is value adding and how much we can how much we can add value 1 4 5 5 6 XOR 7 8 9 10 11, 12 and 13, 14, 15, up to 15. In if will be first, if move one value will be 16, then what will be happen? Total value has been 17 and LED has been off. Means that in or bitwise is inclusive, or we can store value source A in source A 16 and source B 16. Example for source B. If source A value will be 1 and source B value will be 1. So 1, 2, 3, just like control or 1, just like store, just like store or was value, or move to 4, 5, 6, 7, 8, 9. Please observe 10, 11, 12, 13, 14, 15 and 16. So when our value is 15, or move to, when our value on or move to, and or move to means that move or 15 move in or 2 value or 1 source A value 1 and source B value 15, our output 15, or out 15, and when our out 15, then LED will be on. LED is on. Example means that we can store in or bitwise exclusive or 16. Also we can store 16. Means that 15 is source A 15, source B 15. So what will be happen? LED will be on. Means that 15 into 15, 225, 255. We can store the value 255 in bitwise exclusive OR. Means in move 1 source 1 15 and or 2 15, we can store R1 0 to 15 means 16, and R2 0 to 15 means 17, total value 17. We can store the 0 to 15 16 value, or 0 to 15 17 value. So it is a or bitwise inclusive OR gate or instruction. So thank you for watching my video. If you learn or if you like my video, so please hit the like button and subscribe my YouTube channel for never miss get update and instruction in Studio 5000 Logic Designer. In my previous video I already discussed about, you can see here, bitwise instruction and or bitwise instruction. Also other instructions like AND gate, OR gate, NOT gate, logic gate, timer, counter, John timer, T off timer, RTO timer, and also compare blocks, less than, greater than, less than, equal, greater than, equal, not equal, and also bit induction, counter induction, peon timer, and compare blocks, and also compute math induction, logical move induction. So if you new on my YouTube channel, so I recommend you for your better understanding. Uh, Please visit on my YouTube channel playlist. That is the name of Studio 5000 Studio 5000 for beginner, and watch one by one video for your better understanding. So let's get started. Take a new run, and now select logical move logical, and select off select off not, and take another run, and we can write any name, example not underscore one, and right click, if you want to you we if you want you can write description related to the logic. Data type base alias, data type base alias. Base means memory tag, alias means input output tag, produce and consume tag. We can use produce and consume tag for PLC to PLC communication, or PLC to PLC communication. I already discussed about all in my coming video when I okay. So take a and destination should be not out, and right click, new tag, create a new tag, and click on bit, take off another output in run number 14, not out, take a move block, take off a move block, move, or device intersection, move, take compare 1 to example 1 to 10, and text will be not out, copy and paste it here. Already use LED number 25, LED 26, new tag, today, say we can use -8. Okay, we can use -8 from -0 to -8, -9. Okay, -9, -10. Okay, -11. Okay, -12. So So how many number we can use in source A in -1, -2, from -2 start destination, -3, -4, -5, -6, -7, -8, -9, -10, -11, -12. Okay, so we can use not in not bitwise, we can use bitwise not gate. From bitwise not gate, value in minus from 0 to -10 means that 0 to -11 means that total 10, 0 to 10. We can use 0 to 10 in NOT gate. For example, our any value, for example, any field value coming from the 24 volt in minus, but in minus 0 to -11. So we can use bitwise NOT gate, and with the help bitwise NOT we can easily start or stop motor or open or close any valve. So thank you for watching my video. If you learn my video from my video, and if you like my video, so please hit the like button and subscribe my YouTube channel for.
Welcome back to my YouTube channel KS Automation. So in this video today I discuss about how to use LIFO, how to use FIFO, first in first out, and first in first out load, and also first in first out unload. So in this video I already discussed about how to use timer instruction, input output, compare instruction, and also compute math instruction and logical instruction. Right now I am discussing field shift, file shift. How to use file shift in the file FFL load and FFL unload. So let's get started. Take a new run and select from here FFL, FIFO, last in first out. You can absorb name last in, right tag of last in first out source, FIFO _1. You can write anything tag FIFO _1. I already created this tag. LIFO, right name here, source LIFO, and data type of the LIFO. Data type will be of the LIFO is
din, click on as OK. Then here item, LIFO tag is created. So what is the question? Here a question. Imagine you are designing a conveyor system for an manufacturing facility. The item is responsible for transporting item from a loading area to storage area. You are decide to implement a FIFO, last in first out. You are decide to use FIFO, last in first out for implement this logic approach for managing the item on the conveyor belt. LIFO last in. So initially in the last in load initially in the load condition, the conveyor belt is empty for item labeled 10 items. So how many items in the conveyor belt? How many items on the conveyor belt loading? 10 items. So here write LIFO _1. You can write anything name, right click, new tab, data type, LIFO, LIFO _1, and data type, select data type, dimension, select dimension, and select 10 because why I am selecting 10, why I am select dimension 10 of the data type, because for the item labeled on the 10, so 10 item on the conveyor. Select OK, click on create and right click, select from here -1, load -0, and here select item control. It is a tag item select item control item control, click on new tag item control, and data type is by default the control. Create a tag. So our our LIFO is FIFO load instruction is ready, and how many length is 10 because of how many items on the conveyor loading 10 items. Next, if are loaded into the conveyor belt sequentially mean that one by one in that order, when 10 items on conveyor, it is in first condition. So take another bit, select from here bit and write here FIFO start. You can write anything tag and ONS underscore ONS and right click from ONS to ONS 0. So when loaded all item into the conveyor belt sequentially means that one by one in the item order. When the 10 item loaded on the conveyor, then LED should be on. And what is the next? PIFO load, PIFO unload, PIFO. FIFO unload, LIFO unload. After all items are loaded, a LED should be turned on. When all items unloaded, a LED turn on when all item is unloaded. A LED turn on when all item after all item loaded. A LED should be turned on. So after all item unloaded, a LED should be on when item is unloaded. So take another run and copy and paste it. Change from LIFO load to LIFO unload. And you can change the tag LIFO load, LIFO unload. But controller tag should be same, because control tag should be same of the LIFO load and also LIFO unload. And destination should be LIFO conveyor. Right click, right click, new tab and create. Item tag and also FIFO tag should be same. FIFO start -1 and ONS -1.
So when items are loaded on the conveyor, then LED should be on. So take another rung, and when items should be loaded, LIFO 1 take another bit. When what will be happening when 10 items are loaded on the conveyor? Take a no, and here write LIFO FIFO FIFO FIFO. Then item control, here write item control done with, and take a output. Take a empty operand and write here LED 27. LED underscore 27. We can use 27-1 and copy and paste it. What will be next? FIFO unload. After all items are loaded, a LED should be turned on when item is loaded. So when item is loaded, so conveyor will be empty. EM means that empty. EM means that empty. So when conveyor will be empty, when conveyor will be empty, then another LED should be on. LED number 27-1. Save. Save and select communication path RS group. Click on download. Select download. I want to right now conveyor is empty. Item control, conveyor is empty, so LED is on. Example, when in the conveyor loaded one item is loaded in the conveyor, so we can see here from monitor tag one item is loaded on the conveyor or not. Before load tag is before that
is increasing of the FIFO load. 4, 5, 6, 7, 8, 9, and 10. When 10 item is loaded on the conveyor, then LED is on. We can see here 10 item is loaded on the conveyor. Same opposite of the FIFO load, if 10 item unload from the conveyor, so what will be happen? It's very important, so please listen carefully and practice on this instruction. Click 1. We can see here decrement is start. FIFO 1, 2, 8, 9, 7, 6, 5. Observe when all item will be unloaded from the conveyor, so LED should be on. Which LED? LED in conveyor impede LED. Item control impede LED 27-1 should be on. We can see here all item is unloaded from the conveyor. LED is on. So that's we can use LIFO, we can use FIFO in anywhere and any project. On conveyor project, it is mostly used conveyor or conveyor line project. It is mostly we can use conveyor line project or any other industry. So thank you for watching my video. If you learn or if you like from of my video, so please hit the like button and subscribe my YouTube channel for never miss news update. Thanks. Have a great day. Keep learning, keep going, keep watching. Thank you so much. In this video, I discussed about LIFO, last in first out. Short abbreviation of LIFO is last in first out. I already discussed about, you can see on the screen, I already discussed about FIFO, first in first out, in my previous video. And I already discussed, if you want to learn from basic to advanced industrial automation, so you can visit on my YouTube channel playlist, which is uploaded on YouTube, my YouTube channel KS Automation playlist for beginner on Studio 5000. So you can learn from all instruction. You can see all instruction from basic to advanced, from just like I covered all video in my on my YouTube channel. Timers, counter, beat, alarms, timers, counter, set time, T on timer, T off timer, RTO, timer, counter, up, counter, down, reset, and output bit, compare, limit, MSG, compare, CMP, limit block, equal, not equal, less than, greater than, less than equal, and also greater than equal, and also all compute math instructions, CPT, plus, add, subtract, multiplication, and also divide, ABS, native, and logical instruction, move, and, or, XOR, not. And right now I am discuss about study in my previous video FIFO, and today I discuss about the LIFO, last in first out. So let's check what is the last in first out. So take a new run and FIFO, first in last in first out. You can see the instruction help. So last in first out is only available the ladder diagram. You can see in the FIFO ladder diagram, FIFO available only ladder diagram, not available function block diagram on and structure test language on Studio 5000. And operands. There is a data conversion rule, mixed data type within the instruction. So in the FIFO operand type format description. So source is source of the data. So right of the source is right of the data. Next in LIFO. Next in FIFO array data type description. FIFO modify a specific first element of the FIFO. We can set the in FIFO element send, int, dint, the real and string type data. Control tag, control that format of the tag is tag. Control structure operation typically use the same control associate. LIFO U means LIFO O and LIFO U, LIFO load and also LIFO unload. So LIFO load, LIFO unload in the both instruction control data has been saved same. Control data will be same. Next control structure. So in mnemonic data type and description. EN data type. What is the data type of EN bool? The enable bit indicate FIFO instruction is enabled. When FIFO instruction is will be enabled, so on that time enable bit will be high. TM. The done bit is set to indicate that the FIFO is full. POS means position of equal to length. When position equal to length, then done bit will be high. And next is EM. EM means empty bit. When FIFO is empty, if LEN means length data less than or equal 0 or position data less than equal 0, EM bit and done bit both will be high, because both if both length or position both data will be 0 equal, then EM means empty bit and DN means done bit, both data bit type will be both bit will be high. So let's check how it will be work. So question is, imagine you are designing a conveyor just like a previous example for manufacturing facility. The storage area you are decided implement LIFO first in first out. First in first out approach, you decided to implement a FIFO first in first out approach for managing item of the conveyor belt. So let's see how it will be possible. So source tag of the FIFO will be FIFO underscore 1. Sorry, LIFO underscore 1, and LIFO length data type will be LIFO and copy and paste it LIFO underscore 1. And what will be data type of LIFO? Array data type. So already created the data type array in the LIFO. If you don't know how to create, so click on the data type and select the predefined data type. Here we can write int. We can take the data type int, dint, sint, and int, sint, int, dint, int, sint, dint, also real. So you can see I am writing dint and array data type dimension 10. Okay. Tag has been created. Click on apply and click on OK. Control tag. Item control item control underscore. LIFO tag has been created and take a bit and no bit and take another bit ONS underscore 1 and ONS. I already in my previous video I already created the tag of FIFO for ONS. So tag 0, I use tag 0 for FIFO, tag 1 for FIFO load, FIFO unload, and ONS tag 2 for LIFO load. Right click, LIFO underscore start and copy and paste it. FIFO underscore 1 and for ONS right click, select ONS 3 ONS 3 load, and from here select row to LIFO last in first out unload. And what will be tag of the LIFO unload? LIFO unload tag will be LIFO and destination will be conveyor underscore 1. So what is the problem? Here is a problem. LIFO so for FIFO Initially, the conveyor belt is empty. Four item is labeled on the temp item are loaded into the conveyor belt sequentially. Sequentially means that one by one. In the order, then LED should be on and FIFO unload. After the item unload, a LED should be on, turn on when item is unload. So let's see. Take another rung and take examine O, examine on XIC. When conveyor, all item will be loaded. First, initially conveyor is empty. For item level 10, item are loaded conveyor belt sequentially. In the order, when 10 items are loaded on the conveyor belt LED should be on. So in the LIFO description wall will be saying of the LIFO description. What is saying of FIFO description? Sorry, LIFO description is saying the done bit set indicate that LIFO is full position equal to the length. When position will be equal to the length, then LED will be on. So here take a one output for LED and here item control 1 done bit. When length equal when position equal to will be when position will be equal to the length, then LED should be on. So length DN bit and output here LED underscore 27 dash 27 27012 and copy paste it. Second condition, when all conveyor, when item unloaded from the conveyor, then LED should be off on. Next LED should be on. Conveyor will be empty after the done bit. So let's check how it will be work of FIFO. So select communication and select communication software. Select communication and click on download. And if you want to, you can read the schedule of dangerous schedule of the software. I already read. right click on download. So let's check how it will be work. Select controller program remote mode to run mode. Remote program mode to remote run mode. So right now conveyor is empty. So let's start LIFO 1. LIFO. Select, click on toggle. Again click on toggle. 1, 2, 3, 4, 5, 6, 5, 6, 6 item has been loaded on the conveyor. 7, 8, 9 and 10. So our question what is it? When conveyor is loaded, when conveyor on the conveyor, question is before for item label 10 item loaded into the conveyor, so item label 10 item are loaded into the conveyor belt sequentially in that order. When 10 item are loaded conveyor, then LED should be on. So you can see here LED is on after the loaded 10 item, and when decrease 10 item means from the conveyor load 10 item, and after the load from the conveyor unload 10 item. So example, if in the conveyor loaded 10 item and one item is extra coming from the conveyor belt, so what will be happen? So nothing will be happen. Conveyor will be not accept the next item. You can see conveyor is not accepting the next item. Okay, so let's decrease a item from the conveyor. 8, 7, 6, 5, 5, 6, 4, 3, 2 and 1. So from the conveyor unload all items. So now conveyor is empty. When conveyor will be empty, then again item E empty. We can do more and more, we can think more and more about according to the requirement on the conveyor belt. So with the help of LIFO and FIFO, we can easily design any conveyor belt or any bottle filling line, any conveyor belt, all of conveyor belt, bottle filling line, and any liquid filling line. according to your requirement. Thank you for watching my video. If you learn or if you like of my video, so please hit the like button and subscribe my YouTube channel for never miss get update. So hello everyone, welcome back to my YouTube channel KS Automation. So in this video I discuss about how to use AFI and also how to use T&D temporary in. So let's see what is a AFI. If AFI, short abbreviation of AFI, we can say always false, means that we can put anywhere or any run AFI in the program for false any output. So example when let's see what is AFI. So help and see what is AFI available in language ladder diagram. In the ladder diagram available in FI function block diagram, this instruction is not available function block diagram. Structure test, this instruction is not available in structure test. Operand ladder diagram not. And description, AFI instruction set its enable out to false. Enable out to false means that any output or any run, we can put any run or any output for the false operation. What will do with the help of AFI? Example, we have written a logic, but right now run of the logic is not required. So you can bypass logic the run, but how? Let's see. We can use AFI, always false. Example, it is a logic, normal logic, input output, and input output holding and breaking concept, which is we discussed is my first video when I uploaded on my YouTube channel. So let's see, we have not required to output on. Program has been downloaded. Program has been downloaded. Done downloading. Change control mode back to run mode. So let's see, when input number 18 turn on, so and input number 19 is turned off right now. So we can see here should be supply will be passing from input to output, but right now supply is not going from input number 18 to output 18. Example, if I deleted the AFI, so what will be happen? We can say accept the pending edit of the program main program. So we can see again finalize this operation.
so output is on. Example, right now we have not required output on. After the input on, so what we can take a fi and put fi after input number 19. Again, accept pending edit program, also finalize edit program. So we can see input number 18 is on, input number 19 is NC always NC, so AFI always follows the run. TND, right here name of TND. So what is a TND? First introduce the TND. What is the operation of TND? Work of TND. So available language ladder diagram. In function block diagram is not available. And structured text. In the structured text available the TND. Operand ladder diagram. So description. When enable the TND instruction act as a end of the routine. You can you know that last routine, end routine is we cannot use end routine, just like if enable TND, so all routine from TND routine to last routine will be not operate. If the TND instruction is in a subroutine, control return to calling routine. If the TND instruction is main routine, control return to next program within current task. So we can use control we can use TND in the main program also. Control return next program within the current task. Right now let's see what will be happening. We have not required to run number 19 to run number 49. We have not required the logic. Change control remote program mode to remote run mode. So enable of the TND bit. TND bit is enabled. So right now we have LED turn on off toggle. So we can see LED 10 supply going from here to from input to output, but LED 10 is not on. Example, let's see next example. Timer on, right click and click on toggle.
So we can see timer is not starting because from rung number 19 to rung number 48 all logic is bypassed. Example, we have required to move counter. We can see nothing will be happening. So this operation use example FIFO. Just it is my previous video use the FIFO. So FIFO is not working. FIFO start. FIFO not loading the item in the length. So we can use TND for bypass all logic. If after some time we require to operate, easily turn off the TND and we can see operation is start. We can see timer is on. Also we can see LIFO is again counting the length. So in both operation we can use for control the program. So thank you for watching my video. If you like our video, so please hit the like button and subscribe my channel.